today's Leetcode daily challenge question. So the question is regions cut by lashes. Okay, so we are given an n cross n grid composed of 1 cross 1 square, where each 1 cross 1 square consists of this characters. Okay, so and blank space. So these characters divide the square into contiguous regions. So given the grid represented as a string array, written the number of regions. So instead of this backslash, this is represented as this. Okay, so here if you consider this example, we are given a grid of size 2. So here first you can see, in a string there will be only two characters as the size is 2. Okay, so this is empty string, empty character, and this is this slash character, and this slash character and empty character. So if we see, so this will be in matrix form. How we can represent is 2 by 2, 2 cross 2 matrix. So if we see, this is okay. Now here empty and slash. So here if we put this slash, okay, slash, and initially it was empty. So similarly here we have slash and empty. So here you can see this slash, here it is represented as like this, but if we connect both, then our this matrix is divided into two parts. So we have to return number of regions. Okay, number of regions which will be formed after after placing this in the matrix. Okay, so you can see 2, so it is returning 2. So if we see this example, here also we have the size is 2, so 2 by 2 matrix if we consider. Then first is empty character, then slash, then in the next row both are empty characters. So how many regions we can see? Only one region is formed. So in the third example, here you can see the size is 2 and number of characters in each string is also 2. Okay, so instead of backslash, it is representing as a like twice of it. Okay, but it is a single character. Okay, so first in the first row, first it's slash, then backslash. Again in the next row, first is backslash and then slash. So how many regions it is forming is 1, 2, 3, 4, 5. So it is returning 5. So how we can solve this question is, we can use the concept of BFS. Okay, how we do in graph that different connected or disconnected graphs are there. So we count number of disconnected graph. Okay, so here instead of this lines, if we see this example, here if I do 1, and here also 1. Okay, or any number you can select, or like, so how many regions it will form? This and this 2. So if we have, let's say we have this all. Okay, this is not this. So instead of this, let's consider, okay, for better understanding, let's consider single row as three cells. Okay, so here we have only two rows. So if we consider for one row three cells, okay, then for two rows it will be six cells. So it will be, this is one cell, this okay, so here start from here, this is one cell, this is second, then this is, these are two rows. Okay, so here if we consider this, okay, so this is our single cell. So here we have our slash. So if we put one on this first cell, this as consider as a slash, and in the next character which we are given is considered at as backslash. So we can write our backslash like this. Okay, so in the next row we have, let's say, empty characters we are given. So how many regions it will form? It will form two regions. One is this. Okay, so one is this, and the other one is, so all this you can consider um, is the same color. Okay, so you can see we have two regions. So these regions are separated by what? Separated by a number, which we are saying 1. So if we have slash, we can put our number like this, and if we have backslash, then like this. And if it is empty, no need to do anything. Okay. So once we form this matrix, okay, this matrix, then we can use our flood fill problem example, right? So like that, here we can use the BFS to find out. Let's say this is our slash and backslash representation, right? So from here if we start, okay, we can check its adjacent. Okay, so if it's adjacent r1, okay, and there is no more cell single this small cell present with the let's say initial default value is 0 0, no cell adjacent cell is present which has 0 as a number, then we can say this region is completed and we will increment our count whatever we will take as answer. Okay, then we'll start again from here. Okay, so we'll use the BFS and we'll use Q. Let's say, for example, from here we are starting. Okay, so we will consider 1 as a visited and 0 as a we are not visited. Okay, so here we are starting from here, so here it is already visited, so we will increment. Okay, so let's say we are starting from here, it is a 0, then we will find its next like adjacent elements. Okay, so this for this cell what are adjacent, this, so in four direction we'll finding. Okay, so if you see this adjacent, this is not visited because its value is not 1, so we'll insert in the queue. Okay, and other two are visited. So to check, okay, now we have four directions, so we will check for all direction, and also we have to check our condition that this cell exists or not. So you can see on above, or like upward, this cell is not present in our matrix, so we will not consider this. So we'll say this, we can insert this in queue and make it visited. Okay, now for this cell which are adjacent, this one and this is already visited and this does not exist, so two are present, so we'll insert this two in queue and make this as visited. Okay, now so these are in the queue, so we will traverse this. So this for this what are adjacent, this and this, so we'll insert this in queue and make it as visited. Now we have inserted this right earlier, so we'll make it visited and its adjacent are already visited, and this already we have inserted in the queue. Okay, so we will visit it, adjacents are already visited, we will also make this as a visited. Now we have no cell or no element is present in our queue, so we will get out of loop, right? So this one region is completed. Now from next we'll start here. Okay, so similarly we'll do for this, then we'll get two regions. Okay, so if let's say, wait, yeah, so if we have here also backslash or slash. Okay, let's say here we have slash, then same thing whatever we have done, this will be executed here, and there will be no cell adjacent cell which will be present which is not visited, so we'll move for this region. Okay, so in this way we can count our number of regions using this BFS solution. So let's start coding. So here, okay, so first what we have to do, first we have to build this this matrix. Okay, what will be the size of this matrix? So our grid size is 2 and the matrix size is 6, so we have to multiply by 3. We are considering one cell as 3 by 3. Okay, so for better understanding. Okay, so here we will declare one array. Okay, is equal to new int. First we need one, let's take variable int n equal to grid dot length. Okay, and we will be using here n multiplied by 3, n multiplied by 3. Okay, so this will be our array. Now let's traverse the rest this array, and I is equal to 0 is less than n I plus plus. Okay, so for int as j is equal to 0, j is less than n, j plus plus. Okay, now how we will get to know that? Okay, so first we got our slash, so here we have like inserted one, okay, in the diagonals. Now for the next one, okay, for the next one, for I, for let's, these are our indexes, so this 1 2 3 4 5 6. Okay, so after first cell we have inserted this one, then for next one we need our pointer here, our I pointer here. So what we can do is we can multiply our I by 3. So initially I is 0, if we multiply by 3 it will be in 0 because we want the same. If because every time we are incrementing I. Okay, so we will multiply that I into 3, so 1 into 3 will be 3. Or you can make use of I is equal to, instead of I plus plus, I plus equal to 3. Okay, so let's do first. Here we need our int, let's say row equal to I into 3, int call equal to j into 3. Okay, now if our, if, okay, we our grid. Okay, so why we are not doing I plus equal to 3? You can do this, but we have our grid, right? So we have to traverse this grid, but we also have to insert our ones according to these characters. So we are taking other variables to do this, or else you have to keep track of one other variable for this grid. Okay, so if our what if our grid of I, okay, dot char at, so grid of I will return us this string. In that, our char at j, if it is equal to what, if it is equal to slash, then what we have to do, or okay, else if grid of I dot char at j, if it is equal to backslash, then what we have to do. Okay, so here here what we are gonna do is we are making our diagonals as one. Okay, so this will be considered, this is our row and column, that is 0 0, this is 1 1, so we will add 1 to each, that is row plus 1 column plus 1 for index. Okay, and this will be row plus 2 column plus 2. And if it is backslash, let's say our index is I and j, row and column are here. Okay, so we have to add 2 to our column. Okay, so one will be row and column plus 2, one will be row plus 1 column plus 1 will be row plus 2 and column. Okay, so this here for slash, what we have to do is our arr of row column equal to 1, arr of row plus 1 column plus 1 equal to 1, arr of column plus 2, wait, here it is row, right, row plus 2 column plus 2 equal to 1. Okay, now here for backslash, if we copy the same, okay, what, row plus 2 column, okay, row plus 1 column plus 1, here column plus 2 row. Okay, now after this we will get our matrix. Okay, so we got our this type of matrix. Now we have to apply our BFS algorithm. So for that, first let's say one variable int answer is equal to 0. Okay, we will use this loops I is equal to 0. Now I is less than, okay, now we are, what we are doing, we are traversing this, right? So what will be length, n into 3. So here what we will do, I less than n into 3, I plus plus, for int j is equal to 0, j into 3, wait, j less than n into 3, j plus plus. Okay, now if, okay, um, if what, it is not visited. Okay, so we are considering that if the cell contains 1, that means it is visited. Okay, so arr of what, arr of I j, if it is equal to 0, then only we will call one method which we are going to write BFS algorithm. Okay, so if let's say recur, okay, or let's say just bfs, okay, where we'll pass our arr, I and j. So if it is not visited, so in this case what I said is this is visited. Okay, so the here it was not one, right? This is visited, so we'll skip this element or this cell and we'll start from here. Okay, so this is not visited, so we will pass this cell to our BFS algorithm, where it will check its adjacent elements. Okay, this adjacent. Okay, now BFS, then our answer we will count. So only one, what we already said is, here after traversing all this it will return, because there is no cell which is not visited in this region. Okay, so that is why we are calling this as a region, it will return. Okay, and next, from next it will start here or here. Okay, now answer plus plus, and at the end we will return our answer. Now we have to write our own method, that is BFS. Okay, which is not returning anything, which is just traversing. Here we have int array, 2D matrix, int row, int column. Okay. Hmm. Now here what we want one queue, as we are using BFS. So let's say queue. Here we will pass our index. Okay, queue equal to new linked list. Okay, now we have to insert in queue dot push or add what, new int we are passing it row and column, row comma column, and we have to make it visited, right? So arr of row column is equal to 1. Then while loop till our queue is empty. So queue dot is empty. Okay, now let's we want um, our cell. Okay, so here we will queue dot hold cell got our cell. So here what we did, we have pushed this. Okay, so in here after entering in this loop it will pop, or okay. So if now what we have to do with this cell, we have to check with its directions. Okay, so let's make an array. Okay, um, let's create an array of direction. Int int direction. What direction we have is we have four directions: upward, left, right, and down. If we want to go from current to upward, then what we have to decrement or increment, we have to decrement our row because we are going upward. Okay, if we want to go left, we have to decrement our column. If we want to go down, then we have to increment our row. And if we want to go on the right side, we have to increment our column. So let's say 0 comma 1. Okay, this will be we are going right side. 1 comma 0 will be we are going down. Minus 1 comma 0 we are going up, and 0 comma minus 1 we are going left. Okay, so these are our directions. Now we have to check with all directions, right? Let's say I 0 is less than what, 4, 4 I plus plus, because we have four directions. So let's say our int new row will be what, it will be direction of 0, direction of first I of 0. Okay, so plus what is cell of 0, int n column. In cell also we have row column. Okay, here what we are inserting, row comma column. So here direction of I of 1 plus cell of 1. Okay, now we got our row and column, but this should be valid, right? So for this is also so this is one direction which is not in the matrix. So this, if we try to access that, it will get index out of bound error, right? So yeah, we have to what we have to check with if condition with what, first n row should be greater than 0, and n column should be greater than 0, and n row less than what, our what is our size, row and column size are n into 3, right? Or like we can say arr dot length directly, and n column less than arr dot length. No, and it should not be like here you can see for this we have this as adjacent, this as adjacent, which are already visited, right? So we don't have to consider that. So arr of n row n column should be 0. That means it should not be visited. So here then what we will do, then we will first make our arr n row n column. Okay, as or let's say not here, because this is if condition, we'll make here, or after this loop. Okay, so here no, we have already made this whatever we sell as visited, right? Now we are going to this direction. So we have inserted this, only one this. Okay, and let's say for this we have three directions, so these are in the loop. Okay, okay, now we'll first do this thing. First, we have to insert in the queue. Queue dot add what, new int n row n column. Okay, so we have added. Now here we can. So this loop will be how many times? Okay, we will make our this end row and end column as visited. We can make here or here also. No issue. Let's make here because if the condition satisfies, then only we are checking, right? So error of n row n column is equal to 1. Okay, that means for this, okay, for where it is, for this, um, where will it went? Yeah, here. So for this, first we have inserted this element and we have already made it as a 1, marked as it as 1. Okay, so these are, now we have inserting this. So after inserting this, we have also marked it as 1. Okay, then while checking, when we will remove that element or pull that element, then we are inserting this, that time also we will mark this as a 1. Okay, so it is visited. Now automatically it will get out of loop of an, okay, yeah, so we will mark it as a 1. So it will after traversing all, okay, there will be no adjacent element and queue will be empty and it will return. So here we will increment our answer. So let's run. We have some compile error that cannot be, what, yeah, here while declaration, here we have 2D array, right? Is there any other error? Let's check. Okay, everywhere it's like illegal initializer for int. Okay, so we have directly used it, but int font. Okay. Mhm. Yeah, here it should be new, right? New int. No, not necessary. Here it should be like 2D array, right? Okay, we are getting wrong answer. Let's check what is wrong. So this is okay. So I0, J0 less than 3. If it is slash, grid of I, caret J, okay. Row column 1, 1, row plus 1, column plus 1, 1, row plus 2, column plus 2, 1. Here also row plus 2, column plus 2. Okay, this is also okay. Now our answer is 0. I plus plus if VFF is, we are calling R 0, 1, 1, 0, minus 1, 0, 0, minus 1, Q. Then here we are added and make it as 1. Case empty less than 4. Okay, so it is correct, right? 0 and 1 and row and column. Hmm. So what answer we are getting is expected to, expected 5. Okay, let's check for this. Okay, so if we mute here, if condition is okay, if we want to check it, right? Now I is 4, so is this checking in all direction? 4 directions. Yes, cell. What's wrong? Okay, so it is marking everything as 1. So yeah, because it is visiting, right? So let's just comment it out. Then yeah, for this example, it is okay. So maybe this is it should be like this, right? For black backslash. Okay, so I made here mistake. This okay. So no, it's correct, right? If it is slash, for slash it should be this like this. So okay, so here we have made like this mistake. for this, and it should be like for this. Yeah, this is slash. For slash it will be this, right? This one, two, three. And for backslash, yeah, for backslash it is like this. So let's run now, comment this print, or let's check if it is printing correctly. So it will give us all ones because we are okay. Now you can see the solution is accepted. So we made the mistake here. Okay, so for direction is changed. Okay, so let's submit. So in this way we can solve this question using BFS. And thank you so much for watching this video. If you feel this video is helpful to you, then please like this video and subscribe my channel. Stay updated.